Hello everybody, my name is Hajar Zennouhi. I'm doctor graduated from ENSAM Institute. I'm happy to have this opportunity to share our study with you here today. My presentation concerns a numerical study of PCM melting process inside concentric cylinder. I'm going to divide my presentation into four main parts. After the introduction, I'm going to describe the physical model and basic equations. Secondly, I will be showing you the obtained results, and I will finish by conclusion. Phase change problems with natural convection play a significant role in several industrial applications. This driven by a pool of applications that are associated with this phenomena. A sample of applications include thermal systems such as solar thermal systems, waste heat recovery, thermal regulators of building, and electronic devices. In this study, the melting process of the gallium used here as PCM between two cylinders is simulated and analyzed. In addition to point out some of the natural convection characteristics during the melting process phase change inside an elliptical cavity. The physical model shown by the following figure, where the shape of the shell is assumed to be circular while the central tube is assumed to be circular or elliptical, and can be oriented vertically and inclined at 45 degree angle, which leads to three different heat exchangers. This figure shows the schematic diagram of coordinate system. The thermal boundary conditions are considered as the outer wall was isolated and the inner surface was isothermally heated at uniform temperature of 32 degrees. The phase change is unsteady and governed by the basic laws represented by the continuity, momentum, and energy equations. By the following assumptions, the thermal properties of the PCM are constant but may be different for the liquid and solid phases. The Bosinisk approximation is valid. The liquid is Newtonian. Viscous dissipation is neglected, and fluid motion in the melt is laminar and two-dimensional. The resulting governing equations with consideration of gravity effect can be written as follows, taking into account the foregoing assumptions. The CFD code used in this work is based on unstructured volume method and an enthalpy porosity technique to solve for natural convection coupled to liquid-solid phase change. To better understand the heat transfer during the melting of PCM, thermocouples were installed in several points in PCM domain, showed by this figure, which allows saving the temperature history throughout the phase change process in different points. Here we have the example of the configuration with the horizontal elliptical tube. This figure shows the temperature evolution of different thermocouples. At the beginning of the melting process, the temperature of all the thermocouples rises, keeping the same pace. Furthermore, the heat transfer mode that occurs is conduction. At the melting point, the melting occurs so that the temperature graphs become horizontal. Temperatures continue to increase, but with different pace in this stage. The temperatures that tend to increase rapidly are located in the upper part of the PCM domain, like T1, 2, 3, 7, and 8, which confirms that the melting is upwards. At this stage, natural convection plays an important role which justifies the observed fluctuations. The presented figure shows a liquid fraction comparison between the three cases. It confirms that the shape and the orientation of the interior tube influence the PCM melting, so the shorter melting time is obtained for the circular tube. It can be also observed that the melting time decreases considerably by using an inclined ellipse instead of horizontal one. The reason for this variation is behind the fact that when the internal shape is a circular or inclined ellipse, the hot surface of the internal tube can be closer to the bottom of the shell. At the bottom of the shell, the weak conduction is only responsible of the rest of the phase change. The following are some conclusions driven by the obtained results. The shape is an important parameter for the melting process trend. The use of inclined and circular tube leads to accelerating the melting process, which causes shorter melting time. And the solid-liquid boundary is affected by the formation of vortices. Thank you for your interest.